So now the question is, what happens if you divide a fraction by a whole number or a mixed number by a whole number? Once again, let's talk about the kids' estimation skills. What's this number close to? Even if they say 2, that's not bad, because 2 divided by 4, and I already know they're going to yell 2, but 2 divided by 4, your denominator is larger. So 2 over 4, 2 divided by 4 should give you a number smaller than 1. Ideally, they would say a half, but if they don't, that's okay too. It's good for conversation. So this number is more than 2. It's almost 2.5. I don't know if they'll recognize that. It'd be nice if they did. But still, 2 divided by 4, my answer should be somewhere more than a half. And if you want to plot it out on the number line, that would be kind of tough because you're looking at a smaller piece divided by a bigger piece. But that should also help them understand you're going to get a number smaller than 1. And that's a great place to start. So when they start to get a feel for these numbers, I think we've won in some way. So this one might seem a little awkward, but it's kind of pretty, it's pretty neat. So there's 2, and then 3/8. I'll color those in a second. Yeah, let me go ahead and do that. Act like these are all the same size. Because the idea of a model, I mean, ideally they would be perfect, but the model's to help us and help us get structure to the problem. So 2, and then 3/8. And we're going to divide that by 4. So this is an interesting question. How many orange pieces will go in the pink pieces? The kids will probably say they won't because there's not enough pink pieces. And they're right. So now we're talking about remainders. So we get to have those types of conversations. But again, to be consistent with where we were, we want same size pieces. Well, these are all wholes, so they haven't been partitioned off or split up at all. So it's fortunate, because now if we want to talk about same size pieces, we can cut these into 8s. So look at what we're looking at now. How many 8s are here? 8, 8, 8, and 8. There are 32. We have 8 and 8 for 16, 17, 18, 19. So we want to know how many times will 32 pieces go into 19? It won't. So if a kid said it goes in 0 times, I'd be okay with that. So now we have to look at a remainder. It goes in 0 whole times. So what is the remainder? Well, there are 19 out of 32 pieces that we could not get divided. So guess what? That's your answer. And it's a little more than a half. How do I know that? It's a great question to ask. How do you know that's a little more than a half? So even though these are a little more challenging in thought, to actual model them takes a little less work. But then to have them understand that in this case the answer is going to be less than 1 and close to 1/2 actually should have matched with their estimate. But look at the work if you were to work this out. This is 19/8. 19/8 divided by a total of 4. If you were to use the algorithm, 19/8 times 1/4 is 19 over 32. You had 19 pieces that could not be divided by that 32. So if you're using modeling and estimation and the algorithm, their number sense will build. And you can ask kids to create some and try them. Create some and trade with a partner. You don't want them making fractions that are so outlandish that they're difficult to draw, because that's not the point. The point is for them to get a feel for our common fractions and fractions that we see and use every day. And it doesn't hurt. I was in a classroom the other day, and the problem was 2 5/8 feet, and they were making bracelets, and they were cutting them into 1/4 of a foot. So I asked the kid to show me with his hands about how big was 2 5/8 feet. Because if a kid can do that, they are at least putting themselves in the situation. And then I asked him, what's 1/4 of a foot? And he looked right at me and said 3 inches, and I thought that was brilliant. Well, we can't divide by 3 in this case, and we had that conversation. But it was great. So I hope you find this helpful. And if you have any questions, I'm happy to answer them or help you find other models in other ways. But this is what I have. Thanks.